In lesson 5, we're going to look at how to solve rational equations. So the steps for solving rational equations, first thing we're going to do is we're going to figure out the LCD, similar to what we did in the previous lessons. And we're going to multiply everything by the LCD. And what that's going to do is it's going to eliminate our denominators, and it'll make our expressions much easier to work with, or equations much easier to work with. And then we'll just solve for the variable. And one important thing, though, that we have to remember is whenever you're solving a rational equation, you always have to remember to check your answer, because if you remember, we can't divide by 0. So anything that would create 0 in the denominator is going to not check into, or will not be a solution because it will not check as an answer. So you just have to remember to do that. So just always check your answer, because of the fact that 0 in the denominator would create an undefined expression. So when we look at this first example, the first thing I want to do is I want to eliminate these fractions. So I asked myself, what's the LCD between all of the denominators, keeping in mind that this is really 3 over 1. So the LCD between all 3 of these numbers is going to be 6. So 6 is the smallest number that they all multiply into. So what I'm going to do is I'm going to multiply every single piece by 6. And then what's going to happen is you're going to be able to cancel. So really this becomes 6 divided by 2, or how many times does 2 go into 6? 3 times. So really what I'm doing is I'm multiplying that numerator by 3, and the denominator is just 1, so I don't need to worry about writing it. Then here I have minus 3 times 6 is just going to be 18, and it would all be over 1, but again, we don't need to worry about that 1. And then for this one, 6 divided by 3 is going to be 2, so I'm left with 2 times 2, which gives me 4. So you can see I took something that looked more complicated and made it much easier and manageable to solve. Now keep in mind, I could have gone back up to this original and I could have found a common denominator. I could have combined my fractions once I have a common denominator and then solved it that way, but this is definitely a much shorter and quicker way of doing it. So then from here, you just solve for x. So add 18. So we have 3x equals 22. Divide everything by 3. So we get a fraction, and we'll just leave it as a fraction, 22 over 3. Now before I can say that that is the answer, you have to make sure you check. Because if I were to plug this in, and that would, if that were to create 0 in the denominator, that means I'd have an undefined expression, which means it wouldn't be a solution. So in this case, I know that when I plug this in, it's going to work because I don't have my x's in the numerator, not in the denominator, so I know it won't create 0 in the denominator. But again, you could just go through and do the process and check. So let's look at another example. This next example here, we have a slightly different format than the first example. If you see how in the first example I had a fraction minus a whole number equal to a fraction, in this case, it's a fraction equal to a fraction, and whenever you have that, so whenever you have a fraction equal to another fraction, sometimes the most easiest way is to just cross multiply this. So instead of trying to find the LCD, I could just cross multiply. So let me just make a note. So cross multiply when you have a fraction equal to a fraction. And you're going to see some examples later, though, where cross multiplying might actually be more complicated. But in this case, if I were to cross multiply this, you can see that I'm multiplying numbers in just one expression. So that's actually the quickest way to go. So we have 6 times 8 is going to give me 48. Notice I put parentheses around this a minus 4 because it is a binomial. So you have to make sure that you distribute this 3. So I'm going to go ahead and distribute. So 48 equals 3a minus 12, and then it's just solve for a. So add 12 to both sides. So we have 60 equals 3a, divide everything by 3, and we have 20 equaling a. And then I would go ahead and I would check that. And basically by plugging in 20 in for a, I would create an equivalent fraction, so it checks and it works, so that means a equals 20 is my answer. So let's look at some other examples. So now I'm back to this form where it's not a fraction equal to a fraction. It's a fraction plus a fraction equal to a fraction. So you cannot cross multiply. So the only time you can cross multiply is when it's a fraction equal to a fraction. In this case, I have to go back to figuring out the LCD. So my LCD is going to be the smallest combination of these. So it's actually going to be 3 times x minus 2. Since I have an x minus 2, a 3, and an x minus 2 repeated. So that means I'm going to take the original, so I'm just going to rewrite it here. And I'm going to multiply everything by that denominator. So again, I could combine these over here on the left-hand side by finding the common denominator. So I could combine those, and then once I get a fraction equal to a fraction, I could cross-multiply. But again, the quickest way is really just to figure out that LCD and then multiply everything by the LCD. So now I'm multiplying everything by the LCD. And basically, I can do this because it's an equation. So whatever I do on one side, as long as I do it to the other, it's fine to do. And keep in mind that when I'm multiplying by this LCD, it's really like me multiplying 3 times x minus 2 all over 1. So that's why the denominators aren't changing. They're just being multiplied by 1. And that's, again, why I can cancel things out. So I'm actually doing x times 3 times x minus 2, and then on the bottom I'm doing x minus 2 times 1. But if you remember, whenever we multiply fractions, we try to reduce first, which is why I'm reducing anything that I see that's the same. So I can reduce at x minus 2 and x minus 2, and I'm left with 3 times x, which is 3x. And then for this one, I can get rid of those 3's, and I'm left with, I'm going to go ahead and distribute this, 2x minus 4 equals, and then I can cancel out the x minus 2, equals 6. And I took something that's really complicated and I just made it really simple, because now it's just a linear equation to solve. So we're going to go ahead and combine our like terms. So we have 5x minus 4 equals 6. Add the 4 to both sides, so we have 5x equals 10. Divide by 5, we get x equals 2. And before I can say that that's the answer, I need to actually go through and check. And when you check this, for this particular one, you can see right away that if I take 2 and I plug it into the denominator, it's going to create an undefined expression, which tells me that this cannot be a solution. So this doesn't check. So if, I'm just going to write here, doesn't check. And you can actually go through and try it. But I can see just plugging in 2, 2 minus 2 is going to be a 0 in the denominator. So that's why I know it's not going to work. So this is not going to be a solution, and since that's the only value for x I found, my answer is no solution. So let's just look at some more examples with these. So next page here, we just step it up a little bit. It becomes a little more complicated because when you have to figure out the LCD, we're back to first wanting to factor that denominator so that we can figure out the smallest combination between all of these. So anything that factors, you want to go ahead and factor that so that you can look for the smallest combination. So I'm just going to go ahead and do the factors right underneath. So this is going to be quadratic factoring. We're adding to -3, multiplying to a positive. And since we're adding to a negative, it's going to be negative, negative, and we're going to have 2 and 1. X minus 2 is just going to stay x minus 2. This here I can take out a GCF, and I'll be left with x minus 1. So that kind of shows you that when you go to find your LCD, I have an x minus 1 and x minus 1 listed twice, so I really only have to list it once. And then I have an x minus 2 listed twice, so I just have to use that once, and then I have this 3. So my LCD is going to be 3 times x minus 2 times x minus 1. So I'm going to go ahead and just rewrite this. And when I rewrite this, I'm going to rewrite it so that these are in the denominator, my factors, so that I can easily see what's going to cancel. And I'm just rewriting this so that I can see things a little bit better. You could just go right into the problem and cancel. I just want to make it more readable. So then I'm going to go ahead, I'm going to multiply everything, basically the numerators, by this, because the denominator is just getting multiplied by 1. So every single piece. and then we'll start canceling. So we're going to go ahead and cancel. So I have x minus 2, x minus 1. So I'm left with 5 times 3, which is 15. Keep the minus. Those are going to cancel. So I'm going to have a 3 times x minus 1. And again, I'm going to go ahead and distribute that. But what I am going to do is I'm going to put whatever my answer is in parentheses, because if you notice, it's a minus whatever I get out. So it's going to be 3x minus 3. And notice I kept it in parentheses. And then at the end here, the 3's are going to cancel. The x minus 1's are going to cancel. So I'm going to have x minus 2 left. So now I need to go ahead and distribute this negative down here. So I have 15 minus 3x plus 3 equals x minus 2. Combine your x's and combine like terms. So I'm going to go ahead on this side and just combine the 15 and 3. So we have 18 minus 3x equals x minus 2. Let's add the 3x to both sides, and let's go ahead and bring this 2 over. So we have 20 equals 4x. Divide everything by 4. We get 5 equals x. Now we're going to go ahead and we're going to check. So you don't actually have to show plugging in, but you do want to make sure that you're checking, which is why I keep writing check by all of these. And the quickest way is to just take 5 and plug it into the denominator. Make sure you don't get 0. If I take 5 and plug it in, I won't get 0, so that means it will work. But again, you could just plug it into the whole equation and make sure that the left-hand side equals the right-hand side, just like a standard check. So let's do just 2 more like this. So this example here, we have 3 expressions here. So my LCD, again, I have 1 in the denominator here. I have an x and I have an x squared. The LCD is actually going to be x squared because x will go into x squared. So I'm going to multiply everything by x squared. So here I'm going to have 3x squared plus one of those x's will cancel. So plus x equals 10. And then when you look at this, hopefully you're thinking, okay, I'm going to have to factor to solve this because I have an x squared. So that means you need to bring this 10 over. And unfortunately, for this kind of factoring, we have a number in front of x squared other than 1, and we can't divide that number out. So you can either use the AC factoring method where we do factoring by grouping. You could use completing the square to solve it. You could do quadratic factoring. That's up to you. I'm going to do the method where we multiply the 3 times the negative 10, and that's going to tell us the number that we need to multiply to. So 3 times negative 10 tells me that I need to multiply to negative 30. But I'm going to add to this middle number. So I have to add to positive 1. So then what I do is I break this down into 4 pieces now instead of just 3. And the 2 numbers that I pick for the middle have to be positive 6 and minus 5. And notice that I keep the x's with those because they have, when I combine these, they have to come to be 1x. So 6x minus 5x will give me 1x. So then what we're going to do is split it and factor each piece. So we have 3x I can take out of the 2 first pieces. So I have an x plus 2 left. So I should be left with an x plus 2 when I factor out over here. So I'm going to want to factor out that negative 5. So I'll be left with an x plus 2. And then that means that you can factor out the x plus 2 now. When you do that, you'll be left with a 3x minus 5. And now you can set each piece equal to 0. So 3x minus 5 equals 0. So we get x equals negative 2. Over here we have 3x equals 5. Divide everything by 3. We get x equals 5 over 3. So basically you just want to make sure that neither of these solutions would create 0 in the denominator. So you still are doing your check. And they both actually check out. So that means both of them are solutions. So one more like this. When you first look at this next example, you might be thinking, okay, well, it's a fraction equal to a fraction. So you could cross multiply if you want. So you could cross multiply. Oops. Because it's a fraction equal to a fraction. But if you look, when you cross multiply, these numbers are going to get pretty messy, or these variables are going to get pretty messy. So what I would say is to use the LCD method, or multiply by LCD. And in this case, the LCD method is going to be much easier than if we cross multiplied. So I'm going to go ahead and do that. So I'm going to go ahead with starting at the bottom here and factor those so we can figure out the LCD. So this first one I can factor out a y. So I'm going to have y minus 5. The second one is going to be a difference of perfect squares. So it's going to be plus or minus square root each piece. So then what you're going to do is you're going to look at what's the LCD. Well, the LCD, you have a y. You have a y minus 5 in each of them. And then you have a y plus 5. So that means I'm going to multiply the original. So y minus 4 over, and again, I'm going to rewrite the denominators as factors. And then I'm going to multiply each piece by that LCD. And now we can cancel some things. So I have these y's are going to cancel. Y minus 5 cancels. So up top here, I'm going to have y minus 4 times y plus 5. I'm keeping those parentheses because I do need to make sure that I distribute and treat this as a binomial times a binomial. Then the next one here, I'm going to go ahead and cross these off. So I'm left with a 2y. So as you can see, this equation here in green is much simpler than if I would have just cross multiplied. I would have had a y minus 4 times y squared minus 25 equals 2 times y squared minus 5y. It would have gotten pretty messy. So that's why it's better to just sometimes use that LCD method even if you can cross multiply. So for this, in order to solve this, I'm going to have to use the box because it's a binomial times a binomial. So y plus 5, we multiply, so we have y squared, 5y, negative 4y, and then negative 20. Combine like terms, so we have y squared plus y minus 20. So y squared plus y minus 20 equals 2y. And now you can see that I have, again, a variable squared, so I am going to have to factor, so I need to bring this 2y over. So we have y squared minus y minus 20 equals 0. And this one, we can just go right into quadratic factoring with a leading coefficient of 1. We're going to have opposite signs because we're multiplying to a negative. Bigger number is going to be negative, so negative 5 and positive 4. And now you can separate these and set each piece equal to 0. So we have y equals negative 4 and y equals 5. So then what we need to do is we need to check these. So if you go back to the original, so we have 5 and negative 4. So if I take and if I plug in 5, like let's say I just plug in 5 here, I'm going to get 0. So I know that 5 doesn't check, but 4 would. So you're going to check. This one does not check, but negative 4 does. So negative 4 would be your solution here. So let's just look at one last set of examples that we're going to be solving, treating kind of like a literal equation, meaning instead of solving and getting a number value, we're going to be solving for a variable but getting an algebraic expression left. So there's 2 examples like that. So if you look at this next example, we want to solve for y, and our equation here has x's and y's. So basically what I'm trying to do is I'm trying to get y by itself, but we're going to treat these just like the other problems where we're going to start on doing the same techniques that we just did. So when I look at this one here, I can start it by cross multiplying because it's a fraction equal to a fraction. So I'm going to go ahead, I'm going to cross multiply. And when you cross multiply, remember these need to be in parentheses because they're binomials. So it's x times y minus 2 equals y minus 4. 1 times y minus 4. So you don't really need the parentheses there. You can drop those. But then you're going to need to distribute. So we have xy minus 2x equals y minus 4. And now I'm at a stage where now I can start thinking of this back to one of our earlier units where we had some type of scenario like this and you're trying to solve for y. So that means I need to get y by itself. So wherever there's a y, I need to get those on one side and then I need to get everything else on the other side of the equation. So what I'm going to do is I'm going to bring this 2x over. So let's bring that over first. So I have xy equals y minus 4 plus 2x. And then I need to get this y over to the other side because, again, I'm trying to solve for y, which means I need to get y's together. So I have negative 4 plus 2x. And I need to get these y's together, which means I can factor those out. So I have a y x minus 1 equals, I'm just going to rearrange this so it looks neater. So it's 2x minus 4. And then the last step to get y by itself, so the whole reason why I factor that y out is so that now I just have one y, and the operation is multiplication between these. So now I can divide everything by x minus 1, and that's going to get y by itself. So y is actually equal to 2x minus 4 over x minus 1. So you treat them, you start them the same way, and then from there you're just trying to get y by itself. So this one here, this next one, I have x, a, and b, but I'm solving for x. So I'm going to start it off the same way. So we're going to find the LCD. Well, if you look at all the denominators, I have an x, a b, and an a. So my LCD is going to be x times b times a. And I'm going to start it off the same way, where I'm going to multiply everything by that LCD. So x times b times a. So don't really worry about the variable that you're solving for when you start these. Just worry about solving them using the technique. So either cross multiply or multiply by the LCD. This one I cannot cross multiply because it was a fraction equal to a fraction plus a fraction. So now you can cancel some things. So I can cancel out these x's. So I have BA equals, you can cancel out b's, 1 times XA. And now you can cancel out the a's. So we have XB. And again, I'm trying to solve for x. So that means I need to get x by itself. So if you look here, we have an x and we have an x that we're going to be able to factor out, which will get x by itself. So we're going to go ahead and we're going to factor that x out. We'll be left with an a plus b, which will then allow me to divide everything by a plus b to get x by itself. So these cancel, and I'm left with x equals BA over A plus B. And keep in mind, you can't divide by this A plus B until you factor the x out, because basically what that's doing is it makes it multiplication between the A plus B and the x, so then you can divide to cancel it. So then that would be your final answer, and it doesn't matter if you write A times B or B times A, or you can switch the bottom to A plus B to B plus A. So that's it for solving rational equations. In the next couple of videos, we'll start looking at some special cases and application problems.